Math is everywhere. It is omnipresent in our daily lives, from simple numbers and basic fundamental operations to the most complex ones. Whatever else we are not aware of in this planet, math is crucial in every aspect of our lives, especially when we are conducting our research on a considerably large population and need an easier way to compute all data needed for the study, otherwise known as statistics. Statistics is the discipline that concerns the collection, organization, analysis, interpretation, and presentation of data. In applying statistics to a scientific, industrial, or social problem, it is conventional to begin with a statistical population or a statistical model to be studied. Statistics include topics such as interval estimate for population proportion, hypothesis testing, and correlation and regression analysis. These can help to find and count data from a certain sample or population, and it can help us provide a solution to statistical problems in real life. Through the listed topics aforementioned, it is important for everyone to learn what they really mean. In having and providing information on these, it is important to discuss about what they really are and know the full details about these. The first topic to be discussed is the interval estimate for population proportion. First of all, what is estimation? Estimation is defined as the process by which makes inferences about a population based on information obtained from a given problem or situation. An estimate of a population parameter may be expressed in two ways: the interval estimate and point estimate. Interval estimation is simply the evaluation of a parameter, for example, the mean or the average of a population by computing an interval or range of values within which the parameter is most likely to be located. Intervals are commonly chosen such that the parameter falls under a 95 or 99% probability, called the confidence coefficient. Hence, the intervals are called confidence intervals. The endpoints of such an interval are called upper and lower confidence limits. The interval containing a population parameter is established by calculating that statistic from values measured on a random sample taken from the population and by applying the knowledge of the fidelity with which the properties of a sample represent those of the entire population. For estimating a population proportion, first we have a property of a good estimator, which consists of three properties: unbiased, consistent, and relatively efficient.
First property are called unbiased estimator. Unbiased estimator are the expected value or the mean of the estimates obtained from the samples of the given size is equal to the parameter being estimated. The sample variance calculated using a divisor of n-1 is unbiased estimator of the population variance. If a sample variance is calculated using a divisor of n, then it will be smaller than the population variance. There can be many unbiased estimators. To choose among the unbiased estimators, we look at the efficiency. The second property are called consistent. When we say consistent, as sample size increases, the value of the estimator approaches the value of the parameter estimated. An estimator is consistent if its accuracy probability of estimates close to the value of the population parameter increases with an increase in sample size. For a consistent estimator, the sampling distribution becomes concentrated on the value of the parameter it is intended to estimate as the sample size approaches infinity. Because when the sample size n approaches infinity, the standard error goes to zero. The third are relatively efficient estimator. Relative efficient: if there are two unbiased estimator of a parameter, the one whose variance is smaller said to be relative efficient. Estimate have two types, which is point estimate and interval estimate. Point estimate is a point estimate of a population parameter is a single value of a statistics. It is a single value used to approximate a population parameter. Sample proportion is considered as the best point estimate of the population proportion P. The formula of point estimate have two types, for sample proportion and for population proportion. To know the word and meaning of each formulas, here are some following informations. X is the number of sample units that possess the characteristics of interest, and N is the number of the sample or the sample size. X is the number of population units that possess the characteristics of interest, and N is the population size. The point estimate for the proportion of failures is Q hat is equals to 1 minus P hat. This is the following meaning of formulas in sample and population proportion. At point estimate, we call as confidence interval. When we say confidence intervals, it is a range of numbers that contain a population parameter. It is a range of values constructed from sample data so that the population parameter is likely to occur within that range at specified probability. Confidence level describes the uncertainty of sampling method. The statistic and margin of error define an interval estimate that describes the precision of the method. In real-life application, confidence interval were used. During an election year, we see articles in the newspaper that state confidence intervals in terms of proportions or percentages. For example, a poll for a particular candidate running for president might show that the candidate has 40% of the vote within 3% points. Election polls are calculated with 95% confidence, so the pollster would be 95% confident that the true proportion of voters who favor the candidate would be between 0.37 and 0.43. Another example of real-life application are investors. Investors in stock market are interested in true proportion of stocks that got up and down each week. Businesses that sell personal computers are interested in the proportion of the households in the United States that own personal computers. Confidence intervals can be calculated for the true proportion of stocks that go up and down each week and for the true proportion of households in the United States that own personal computers. These are examples of confidence intervals in real-life application that we see and we use. But in order to understand confidence intervals, we need to understand sampling and sampling error. When we say sampling error, a sampling error is a statistical error that occurs when an analyst does not select a sample that represents the entire population of data. As a result, the result found in the sample do not represent the result that would be obtained from the entire population. The next we discuss is the confidence interval for a population proportion. Here is the formula, where P is the population proportion, N is for the number of sample values, P hat is for the sample proportion, Z is the z-score separating an area A over to the right tail of the standard normal distribution. Sample mean is used to estimate population mean. Sample variance is used to estimate population variance. Sample standard deviation is used to estimate population standard deviation. Sample proportion is used to estimate population proportion. In estimation, we don't just calculate it and solving it. Estimation have the following steps that we need to follow. Here are some steps. Number 1. Select sample. Number 2. Get required information from the sample. Number 3. Calculate sample statistics. Number 4. Assign values to population parameter.
The next we will learn is about hypothesis testing. When we say hypothesis testing, it is an act in statistics whereby an analyst tests an assumption regarding a population parameter. The methodology employed by the analyst depends on the nature of the data used and the reason for the analysis. Hypothesis testing is used to assess the plausibility of a hypothesis by using sample data. So, how hypothesis testing works? In hypothesis testing, an analyst tests a statistical sample with the goal of providing evidence on the plausibility of the null hypothesis. Statistical analysts test a hypothesis by measuring and examining a random sample of the population being analyzed. All analysts use a random population sample to test two different hypotheses, the null hypothesis and the alternative hypothesis. So we have 5 steps to test a hypothesis. State your null hypothesis, state an alternative hypothesis, determine a significance level, calculate the p-value, and draw a conclusion. This is the following steps in testing of hypothesis, and this will get the final answer. But before that, we need to know also the types of research hypothesis. A research hypothesis is a specific, clear, and testable proposition or predictive statement about the possible outcome of a scientific research study based on a particular property of a population, such as presumed differences between groups on a particular variable or relationships between variables. Research hypothesis is a statement of expectation or prediction that will be tested by research. Research hypotheses have 4 types, which is alternative hypothesis, null hypothesis, non-directional hypothesis, and directional hypothesis. To know more about each types of research hypothesis, I will explain what meaning of each types of research hypothesis. So first is alternative hypothesis. The alternative hypothesis states that there is a relationship between the 2 variables being studied. One variable has an effect on the other. Second is null hypothesis. The null hypothesis states that there is no relationship between the 2 variables being studied. One variable does not affect the other. Third is non-directional hypothesis. A two-tailed non-directional hypothesis predicts that the independent variable will have an effect on the dependent variable, but the direction of the effect is not specified. The last are directional hypotheses. A one-tailed directional hypothesis predicts the nature of the effect of the independent variable on the dependent variable. Adults will correctly recall more words than children, for example.
The last part of discussion is about correlation and regression analysis. When we say correlation, it is used to test the relationships between quantitative variables or categorical variables. In other words, it's a measure of how things are related. Correlation quantifies the strength of the linear relationship between a pair of variables, whereas regression expresses the relationship in the form of an equation. It is a statistical method used to evaluate the strength of relationship between 2 quantitative variables. And correlation can tell you just how much of the variation in people's weights is related to their heights. The relationship or correlation of 2 variables may be described in terms of direction and strength. First is positive correlation. Positive correlation exists when one variable decreases as the other variable decreases, or one variable increases while the other increases. Second is negative correlation. Negative correlation is a relationship between 2 variables in which one variable increases as the other decreases and vice versa. And third is zero correlation. Zero correlation exists when there is no relationship between 2 variables. In correlation, we see some scatter plot in different types of correlation. When we say scatter plot, aka scatter chart, scatter graph, uses dots to represent values for different numeric variables. The position of each dot on the horizontal and vertical axis indicates values for an individual data point. Scatter plots are used to observe relationships between variables. As you can see, the picture here shows the different types of correlation. We have positive correlation, negative correlation, and no correlation. By determining which correlation, we can see the spots on each graph, and this is what we call scatter plot, and by this, we will know if the graph is positive correlation, negative correlation, and no correlation. As I say that there are 3 types of correlation, which is positive, negative, and no correlation. When we say positive correlation, the spot is straight
and the direction is on the right. When we say negative correlation, the spot is also straight and the direction is on the left. And when we say no correlation, the spots have no direction, which is the spots are scattered on the graph. Drawing of scatter plot is not just drawing, but there are some steps that need to follow on drawing of scatter plot. Step 1. Draw and label the x and y axis. Step 2. Plot each point on the graph. Step 3. Determine the type of relationship that exists for the variables. But shall we just draw a scatter plot? No, we should not just draw a scatter plot, but we use a fit. When to use a scatter plot? When you have paired numerical data, when your dependent variable may have multiple values for each value of our independent variable, when trying to determine whether the two variables are related. The next is correlation coefficient. The correlation coefficient is a statistical measure of the strength of the relationship between the relative movements of two variables. The values range between negative 1.0 and 1.0. Correlation coefficients are used to measure how strong a relationship is between two variables. Correlation coefficient formulas are used to find how strong a relationship is between data. The formulas return a value between negative 1 and 1, where 1 indicates a strong positive relation, negative 1 indicates a strong negative relation, a result of 0 indicates no relationship at all. First, we need to know what is percent product moment correlation coefficient. Percent product moment correlation coefficient, or Pearson's correlation for short, is a measure of the strength and direction of association that exists between two variables measured on at least an interval scale. One of the most commonly used in linear correlation symbolized by R. To compute for R, we use the formula. As you can see on the picture, it is the meaning of each symbol on the formula of Pearson's correlation. The next is about linear correlation coefficient. The linear correlation coefficient measures the strength and direction of the linear relationship between two variables x and y. The sign of the linear correlation coefficient indicates the direction of the linear relationship between x and y. How to find the value of linear correlation coefficient? Step 1. Make a table as shown. Step 2. Place the values of x and y in the column, multiply each x value to y value, and place the products in xy column. Square each x value and place in the column. Square each y value and place the squares in the column. Find the sum of each column. Step 3. Substitute in the formula and find the value of R. The next is regression analysis. Regression analysis is a set of statistical methods used for the estimation of relationships between a dependent variable and one or more independent variables. An independent variable is an input, assumption, or driver that is changed in order to assess its impact on a dependent variable. Regression analysis is a reliable method of identifying which variables have impact on a topic of interest. The process of performing a regression allows you to confidently determine which factors matter most, which factors can be ignored, and how these factors influence each other. We used t-tests to determine whether significant correlation exists between two variables. The next is how to test the significance of R. Step 1. State the hypothesis. Step 2. Compute for the value of t using the given formula. Step 3. Compute the computed value of t with critical value of t. Step 4. Make the decision. Step 5. Summarize the results. The next is about dependent or independent. It is the outcome variable, is also called the response or dependent variable, and the risk factors and confounders are called the predictors or explanatory or independent variables. In regression analysis, the dependent variable is denoted y and the independent variables are denoted by x. What is regression line? Regression line refers to a line through a scatter plot of data points that best expresses the relationship between those points. Statisticians typically use the least squares method to arrive at the geometric equation for the line, either through manual calculations or regression analysis software. Regression line equation: y equals a plus bx, where x is the explanatory variable and y is the dependent variable. The slope of the line is b, and a is the intercept, the value of y when x is equals to 0. To find the regression line equation, there are following steps of it. Step 1. Make a table. Step 2. Find the values of x, y. Place them in the appropriate columns and sum each column. Step 3. When r is significant, substitute in the formulas to find the values of a and b for the regression line equation y equals a plus bx.
And that's all for our discussion. Thank you very much for watching this video. We hope that you have learned a lot while having fun exploring the complexities and real-world applications of one of the hardest fields in mathematics. I am John Kenneth Gonzales, and together with my groupmates Shaina, Shania, and Shaira, we wish you all the best, and may the Almighty God bless you always. Also, don't forget to check out the editor's YouTube channel and subscribe. That's all. Bye!